That didn't lag. Yeah. Yeah.
Just to prevent the cover from.
TracFOG's a PTO driven fogger, okay? It's going to operate using a very forceful high volume of air, which is going to atomize the solution in the nozzles. There's a pump that's going to drive the solution through those nozzles. That's at about 80 psi. We've got 350 psi coming off that pump agitating in the tank. We get really good, robust agitation. Basically what's going to happen is your PTO is going to turn. And on the inside, it comes off, yeah. For easier access. So you're going to turn your PTO shaft. That's going to drive the belt and the gearbox. So one belt is going to be turning basically running the pump. One belt is geared up to run the blower. Okay? That blower is going to push air out through that back tube up into the nozzles. So the pump.
The air going through those blue things, or is that the solution?
No, the air is actually coming through the metal tube.
Okay.
The metal tube.
All right.
And it comes around the solution lines. Actually, that up there is a pneumatic cylinder to switch the nozzles from one side to the other. So in this house, is there a center aisle down there? Okay. If you wanted to fog from the end, you have two nozzles going one way. If we're going to fog from the center, we have them going both directions. But when they're both facing the same direction, there's a switch in the cab that you can flip the nozzle direction over. But when they're facing two directions, you don't want to press that button because it goes one direction, which means one would go under. We want to do that. Adjusting the nozzle is very easy. We'll look at that in a second. In here, so sucking air in for the blower, forcing air up into there. The pump is going to send 350 psi back to this tank for agitation, and it's going to send 80, and we do that through a special bypass loop there that's got some restriction on it. So it's got a constant 80 psi. That's what runs to the nozzles. There's a solenoid valve right back in here that you can activate from the cab for each nozzle independently. So you can turn one on or one off. Say you're fogging both directions and you get to a wall on one side, and exactly. When I shut it off.
Regards to coverage, it's better go both to one side, or doesn't matter if one side and the other?
No, it's really going to depend on the layout of your greenhouse. It's just, the whole thing with this thing for coverage is going to be, and how much area you're going to cover is going to be based on how big the area is, and then volume put into that area. So if we look at this greenhouse, we'll go through and we'll calculate the size of each bay, and we'll say, okay, this needs this much volume of solution to treat this, and we know how long that'll take per nozzle to apply, and so we'll either, depending on the distances we're throwing, we'll either sit in one spot at each bay. So normally you could either roll the tractor on a very slow if it's a shorter distance. If we're going longer distances, we probably want to drive to one spot in the bay, sit for a couple minutes, roll forward to the next bay, sit for a couple minutes. That helps push the pesticide down, the fog down the greenhouse. The HAF fans in the greenhouse should be off during that application, but on when you get out of the greenhouse.
Oh, okay.
I just don't want it blowing back at the applicator at that point. You're going to be suited and everything else, but if we can push it away from you for, stay ahead of it, that's really the goal.
And vents closing, that's only for 2 hours, an hour.
2 hours is probably fine. Vents closed. Vents really should be closed for 4 or 5. So that's going to be whenever you're actually going to run the machine is going to be dependent on that time-wise. Normally you're going to do, you're going to start late enough that hopefully you're not going to get it too hot. Typically this is going to do about 200,000 square feet in about a half an hour. So we're going to move through here at a pretty quick rate. We'll you know, that output can be adjusted slightly up or down, but depending on the flow rate. There's two nozzles back here that govern the flow rate through two restrictors basically that govern the flow of these nozzles. And we'll talk about that when we get to the back of the machine. So this pump, like I said, is going to be saying 350 to here, 80 to there. We want to get, agitation is going to be paramount with this machine. We want to make sure with this, like any other low volume equipment, we're concentrating the spray more than we are with a hydraulic spray. So solubility can be an issue. You know, making sure the stuff stays in suspension is important. The pump has ceramic pistons and Viton seals, which we found to be very good against abrasion. But more importantly than anything else is making sure that this is properly mixed in the tank. That's gonna save your pump more than anything else. So when you're gonna fill this thing up, we want to put in probably 75% of the water you plan on using during the application. Okay, mix up a slurry, get the PTO running so that the agitation is agitating that water in the tank, and then put your slurry in. We don't want to get, you know, water to here, dump your chemical in, you know, and then drive out to the greenhouse and 15 minutes later turn on the agitation. Because what will happen is that a lot of that stuff, especially the ones that we are worried about, are heavier than the water. They'll settle at the sump, and that's what's going to get sucked into the pump, not water and that. So that's a lot harder for the pump to deal with. That just starts ruining seals and valves, and we don't want to do that. So making sure that you're agitating with a lot of water before the chemical goes in, and we don't stop agitating until we're done. You know, that's going to make sure things are well mixed in the tank. You're getting good coverage, but we're also keeping, that's a maintenance issue. We want to make sure we're keeping the pump protected. Okay, so that pump is going to force solution up through the solenoid valves, up through these lines. You've got isolation valves on here, filters and a little check valve in here, okay? And then these nozzles, these little pieces, these are actually the same thing we use on a pulse fog for restricting flow. Don't use the washer. So your solution is going to go through here and out. This hole is restricting the flow. This is what's governing your flow rate up to the nozzle. We can adjust the flow by changing this nozzle, and the box on that, it came over. Did you bring the box?
No.
Okay.
Brought the manual.
In that box, there's a couple of these, different sizes, okay? These same things are also inside, and that's actually what's helping us make that bypass loop of only 80 PSI. The pump is operating at 350, but that little bypass loop there is restricted at one end and then less restricted at the other. So what happens is we drop the pressure and then we open it into a larger chamber and allow more flow out the other end, and that keeps us at 80 PSI, which is all we want at the nozzles.
What's the advantage of changing the nozzle size?
Higher flow rate. Now that will adjust the particle size a little bit.
Depend on how far you want to shoot it.
It's a little bit. Yeah, the distance of throw will change a little bit, but the output time will change a little bit. The particle size will change a little bit. It's
only 4 nozzles.
Huh?
4 nozzles.
I believe so. We got 7s, 10s.
The standard is a 7.
Yeah, 7, 8, 9, and 10.
I'm not sure which other are.
I think it goes up to the 10 is what we got.
Supplied. I think 9 or 10.
So
the smaller the number, the smaller particle size.
That's the whole, basically, exactly. Actually, you get a little bit. The distance is actually, you get more distance with the smaller droplet. Heavier droplets fall faster. Is the issue.
So if you're not in a hurry, you should probably use the lower flow rate. So you get smaller particles, better distance,
Longer
better
hang
distribution.
Time. Yeah. Although we've done it with some other growers, we've gone up as far as a 10. We've got bigger nozzles, but I'm not going to recommend we do those just because what ends up happening is it speeds it up a little bit, which is good. But we also want to make sure we're getting it all the way down the greenhouse. Mid-American's got them where they're only throwing 100 feet either way, and they're using the 10 because they're not as worried about going as far. You know, and what they're doing in the MXs is they actually got one, and they're driving down the center of a house like this, except that, you know, maybe it's 4 bays, 5 bays. They're driving on one of these because they've actually got a tractor aisle in there where the boom's raised up over it, and they're fogging that way because they don't have a center aisle in the house. And they're 900 feet long, so they can't fog from the ends. So that one, they're just ripping down the center where just that one little tractor way, and that's how they're treated. You guys are gonna be able to do it from the center, so it's gonna take a little bit longer stops, but it'll take the same amount of time to fog. Maybe a little less, maybe a little more if we use a smaller nozzle. But we're gonna wanna watch based on distance. Start with the 7s, and maybe you can adjust up a little bit, depending on what we see at coverage in the middle or the ends and stuff like that. Also, the HAF ends will help with that, so I'm a little less worried. You know, as long as we keep the HAF off during application and turn them on afterwards, that'll help distribute it. And we'll get, you know, so if we go to a higher flow rate, that won't be, you guys are set up well for that. Okay, so then the solution lines go in here. Air is coming up through this pipe. Solution lines go in and go to each nozzle, where they come out just behind here, right in here, okay? This is all this is a press fit connection. These are threaded, so you can take that off, clean it out. If anything starts to deposit, you know, if you have a real thick mixture, you're gonna watch stuff in here. If you start to see this gumping up, there's a bunch of this extra solution line that you can change out over time. We can get you more. But this is a good indicator. It's clear, so we can see if you're starting to get deposits in the line. Use a real heavy powder or something like that. It's not coming through here at a real fast rate. It's not a lot of pressure, so you'll start to see it build up, especially like at any joints and things like that. So we want to watch those. So the air is coming around the outside of this and shearing the droplets right here at the tip. One thing we want to do is make sure that, because that tube is in there, see how we're adjusting. So I can adjust this nozzle height position. What I always want to do is make sure anybody using this thing or adjusting it goes over the top. Okay? Don't go 360, because then we're going to start twisting this tube inside. It can take this, no problem. But because of the bar in the middle and everything else that's adjusting your angle, we can twist that in there. All of a sudden you won't get any flow out of there. It'll clog up. That even if it twists and kinks a little bit, that becomes a point for stuff to deposit. We just want to make sure that you're always going over the top with the nozzle angle. So since we were going to fog in the center aisle, we're going to want to aim them so this will be blowing out both directions like that. We then do not want to use this cylinder up here is going to change the position from one side to the other. So this cable, this cylinder drives that way, rotates, pulls the cable, which rotates this cylinder here, which flips it over. We don't want to do it here because that'll push this one underneath. Okay? But if we're fogging one direction, going this way, press the button and this will flip over the other way. So that's end dial application. Alright, so basically that's really the gist of how this works. Simple other maintenance issues. There is a inlet filter right here. Okay, so now you guys are all aware there's a solution filter right there. We need to clean it. Okay, otherwise it'll start clogging things up. This is the tap right here for you can actually shut off flow from the tank. We need to clean it right now. So say you start running it and you forgot to clean it, you use the powder and that's all gunked up and nothing's coming out, we can shut this and still get at it without draining the tank at our feet. There is a...
Don't forget to open it after.
Yeah, make sure you open it. On the other side over here, tank drain. Make sure that's closed before we fill it. We were in one situation where we were just demoing it for people. This is open, there's water in it. You already filled it, Renato?
City water.
God, great. So
Good.
that wants to be, you want to make sure that's closed when we're running it, but open other times. These since it's behind the panel, sometimes you don't always see it to check. So open up, make sure she's going. This has the maintenance schedule. Talk to the maintenance guys a little bit about that. But every single one of these boxes inside here has oil in it. So there's going to be oil changes on it that are going to be regularly scheduled. That's all in the manual. Everything's very easy to access. There's just not you don't have to take anything out to actually access the oil pans to drain them out. 2 oil holes in there. There are air bleeds right here. Do not hose this thing down on the inside with a lot of water because you don't want to get water in through the air bleeds on the blower. Okay, that we can get. We're trying to keep water and everything out of the oil there, and that's there just to account for pressure differential. So don't soak the whole thing out on the inside. Don't take a pressure washer in here or anything else. You can wipe the thing down, but let's not get it really wet.
Screens in the anti-drip?
Yeah, there's filters inside here. They're just small little, basically they're all, you guys have seen these before. Can you open it? There's solution in here or no?
No, we opened them, unless they got pressurized.
You did. Okay.
That's the
Check valve right here.
That's a Viton seal on that end.
And your filter is right here. Just a little, you guys probably even have these sitting around from TJ parts. Okay, we've got them in stock, but you guys ran down and got the pins for this thing down at the tractor dealer down the road. They've got this probably too. The check valve, it's all the same stuff. I would pH regulate it just because of the pesticides. You want to make sure that you're not inactivating them. Clean, certainly if we can avoid grit and things like that, that's going to help because we don't want to clog that filter up. We don't want to break the nozzles or anything anymore. We have to. We don't want to cause any damage to the pump and everything. There is a filter down there, but finer salt can still get through that. City water. City's probably a good idea. The cleaner the water, that's always better after. Okay, yeah, that should be fine. Okay.
Make the water go through the screen that's on the end. So
you did put everything that goes in. Go through that filter back here. Got it? Back. Okay, I think we're ready to
add the carrier. Or do we want to add?
Hasn't been added. The machine to be used, right? Basically, we have a lot of different types of equipment that we make in this company. PulseFOG and the TracFOG work on a slightly different atomization principle than something like the AutoFOG that we make. AutoFOG is extremely precise. You get a very fixed amount of air and the right pressure of air through a very precise nozzle, and you get a more even droplet size as a result. The disadvantage of those types of machines, though, is that they're slow. Hours and hours to do the application. This guy's advantage, this and the PulseFOG both are extremely fast. What they do is they work with high volumes of air to create the air shear at the nozzle. Okay? That's less regulated though. The nozzle, an advantage of that is the nozzle size, the orifice isn't as small, so it's less likely to clog. But also the speed, it's a whole lot faster. The output is a lot greater. You can throw the fog a lot further. So that's the advantage of nozzles like that. The disadvantage of that is that they're a little sloppier in the way that they create the droplets. So because the output is higher, you can end up with a lot of recombination of droplets as they exit the nozzle. So droplet spectrum can be wider, different sizes. What we do to cover that is we use a carrier solution. Basically, it's going to help surface tension of that water so that the droplets aren't going to recombine right out of the nozzle. And it's going to give you, it's also going to create more even droplets than as a result. The more even the droplets, the better hang time and the better distance. We want to try and for as even of a droplet as we can to help get it around this entire greenhouse. This is the exact opposite of what we're doing in the field. We want drift with this. We're trying to create drift. Okay? And then we're moving that around by the air volume out of here, your fans. That's how we're going to get it around the greenhouse. But it's drift that's doing it. So we're trying to make as even and as light of a droplet as possible so we can carry it with that. Basically, the minimum amount of water you're going to use when you apply with this, 2 liters total solution for 10,000 square feet. Okay? And that's going to be 1,750 milliliters, 1.75 liters of water, and 250 milliliters of Nutrafol. So how much water did you put in there? You know?
200 liters?
Oh, you? No, it's
A lot of water.
yeah, 200 liters. Wow.
Yeah.
Just for a demo, it's too much.
Okay, so
Yeah, well,
we're not.
let's dump some out so we don't need to use so much carrier.
Yeah. Well, we can run it without the Nutrafol
Yeah,
too.
that's true.
You know, if you know, but the way the Nutrafol works, so if you had 200 liters in there, so basically this is 1 liter per acre.
Right.
Okay.
And what is it? 7 to 8 to 1 ratio of liter to
7 to 1.
7 to 1 of carrier to water per
1
acre.
liter of that per acre, and how much? What's the usual volume per acre?
7 liters.
7 liters per acre.
Right, per acre.
Yeah.
That's the minimum now, okay? There's going to be products that you're going to find that are a little more stubborn. They don't mix as well, like because the concentration we're going to make, that's basically, you think we're going to put 8 liters total, 2 gallons of water for an acre. You know, some pesticides, that's 100 gallons per acre of water that you would normally use. We're going to get away with a little less pesticide than you would use for that acre, but it's going to be pretty close to the same amount. So we're putting 100 gallons worth of pesticide into 2 gallons worth of water. And that's going to end up being a much higher concentration, so solubility is always an issue. Most products we don't have any issues with. There are some, Met 52, Perforol, some of the living products, especially when you get the clay carrier in there, we want to pour it and make sure we're decanting well. But you're going to want to use more water in solution per area when you use those types of products. So, you know, when you have something like that, adding 50% more solution water per area is a good place to start. That changes the solubility a lot. You know, something doesn't mix well in 2 gallons, but it might mix well in, it might very easily mix well into 3. So we want to make sure that you guys are paying attention to how the solution looks, everything else, because you're the only ones who can be the best judge. We can give you some guidance on that. We work a lot with the pesticide manufacturers and are very well aware of which ones do and which ones don't have issues. Cease is pretty good. Botanigard is pretty good. Cease and you can use millstop in there, but that's going to need more water. Cease and millstop combo is going to need more water. Most of the standard contact insecticides are at this point so soluble and flowable that not a lot of issues with those. Some of your fungicides you're going to need to be added, a little added water.
And when you're adding additional water, make sure you're keeping that ratio the same when you're adding water and carrier. Don't just add a bunch more water. Add that carrier.
If it's add 50% more Nutrafol and water to get to that amount. Okay?
Also the running speed and the pressure gauges.
This is, I told you guys don't have an RPM indicator on or tachometer on here. It's showing you how fast the PTO shaft is running. We have one for the tractor, but not for the PTO. No more than 540 RPM on this, which is basically, the other way to find that out is on this side of the unit, you got a couple gauges. One showing you the agitation pressure, the spray pressure, that's coming out the pump. The air pressure, we don't want to ever, it's going to be up around that 0.6. Not much more than 0.7, right? So
Don't go above 0.6.
okay, so don't ever exceed 0.6. That's where you want to run it. It's close between 0.5 and 0.6. but don't go past the 0.6. So since you don't have an RPM indicator, normally that would be at about, yeah.
How do you depressurize it?
You just spin it down. It's a blower, so it's just gonna spin down. The pump stops running, it'll depressurize itself. But it's just open bypass. But yeah, so that's gonna be your indicator when using it with the track. Very important. The way that this works, I'm taking engine power off the engine over here and transferring it over here. This shaft should be as level as we can get it. Okay? Do not run it with the knuckles bent a lot, or that puts a lot of strain on that knuckle, and you'll wear those shafts out, and you can cause damage to the tractor, you can cause damage to the TracFOG. So you want to have that as level as possible.
Ideally, this should be a little higher.
Right. And adjusted this way. Looks like you guys are going to be getting a couple new pieces for this, because some of them are bent from maybe some outdoor use. That'll help pull it this direction a little bit, but it could come up a little bit too. The way that this shaft works, it's basically a bar and a sleeve that slides over it. It can only go so far. We've cut it down to work well with this tractor, but if you ever change tractors, you want to make sure that that's sized right. Because if this goes too far, that shaft can't slide together anymore. Never adjust the height on the PTO with the shaft running. Okay? What can happen there is now not only do I have my hydraulics lifting and pushing that way, but if the thing's spinning at 540 RPM, we've seen it where the entire base that this is all mounted on got shifted back about 5 degrees because somebody lifted it. The PTO seized, it wouldn't go any further, and all that energy from the hydraulic and the spinning transferred into that, and all sorts of stuff was not in good condition when it was done. So we want it level, we want it not running when we're adjusting the height. But so you want to get it to the height you're going to use it at when you're ready to go. Set it, then start the RPM up on the PTO shaft. Then we're going to add the water to the tank, make sure it's full. You could add water before that. Before we put pesticide, we want enough water in it so that the PTO is driving the pump to run agitation, so that when we mix it in there, it mixes it all well. You ready to give it a shot? That's it. Yeah. For both regular chemical surfactants. This is actually a chelated 10-3-3 liquid fertilizer. The chelation process gives us that water tension reduction. It is a 10-3-3 fertilizer. That one important consideration with this is no more than 5 times a month on the same plant without adjusting your nutrition program. You could start to see some maybe over-nutrients at that point.
See any phytotoxicity?
Really very little. There's very little that we've seen this cause by itself. The only tendency we've seen with this is if you have a product that you know is going to cause a problem, chemical that's going to cause a problem on a plant, we have seen this maybe not eliminate it, but sometimes increase it, and that's because normally low volume you'll actually see less phytotoxicity. But with this product, what you're doing is the plant's kind of feeding. It's actually helping. It's pulling the product in. So if you have something that has a tendency to cause not edge burn type damage, but stunting damage, GR damage, stuff like that, this can increase that because you're pulling more into the plant. So fine anti-bombs is about the only one that I would say don't. From that standpoint, that's the only place we've seen it. Everywhere else, this is working great. We don't see any phytotoxicity with it. If you're familiar with the way if you've seen pulse fogs run, you might have seen a big thick cloud that looks like smoke. One of the reasons in all the old pictures that was being done with BK2, which is an older carrier, it has a dye in it. Okay, so we have a dye that we add to that carrier so that when we fog, it's more visible. We don't add a dye to this. It's still fogging. It's just not going to be as visible as it would be with the dye frame. We decided that was a better issue. We didn't have, you got a greenhouse next to some house. They see this stuff wafting out, they think this place is on fire, call the fire department, and the guy's just fogging. So this carrier solution does not have that. Because we have not added to this tank, the fog's not going to be real visible though right now. Water on its own, you don't see it real well. Particle size is going to be a little bit bigger as a result, so you might not see it carrying far down the house without the carrier solution.
And then you said no more than 5 times, right?
No more than 5 times in 1 month.
A month. Okay.
In a month. That's a guideline. That's a guideline, yeah.
Any micronutrients in there?
There's a yeah, you've got, here's the list, you've got copper, iron, manganese, molybdenum, zinc, no boron. Oh yes, boron, 0.01%. Huh? It's minimal, especially at the amount you're putting it out. Ready?
Yep.
Okay, so you've got the control panel. I think we just run it with water today. You know, the fog is going to look a little bit different when we do this with NutriFOG in it.
You don't want to keep up your days.
Yeah. We don't need, I mean, it depends on how much of a demonstration you really want to see now. You got the vents open. It's not even a bad idea to pull the shade just to have some more hot day like this. It's going to be evaporating more. It's not going to be a real good view of what this does, just because you're typically do it later in the afternoon. You're going to have the vents closed, so you're not going to have it exiting. Curtains full. It's not a bad idea. But okay, so you got your reverse for the nozzles. What do you want to do? You see how they're positioned right now? You want to aim it. You're putting them together. You want to aim the direction of the longer taper. Yeah. So we can turn the nozzle position.
By hand?
No, it's running off the.
Not with all the.
Oh yeah, you need
pressure.
the air. That's right. It's pneumatic. So let's bring the PTO up.
How do you run the PTO on this?
That's your PTO, and that's your problem. So first engage the PTO. It says rear PTO right there.
It's running.
Okay, now slowly bring the RPMs up and watch your air pressure. You got your tractor engaged. Okay, start cranking it up.